Charles Clinton. We're starting off with this video number 5. We're going to talk about attributable risk. So I was actually planning on talking about the different types of attributable risk, because look, this isn't that straightforward. It's not just, hey, look, calculate the attributable risk and you're finished. Might ask you, calculate this one, or this one. So there are four different yeah, calculations that with just implementing an additional word, it means something very different. So usually the basis of attributable risk, or of all these formulas, is definitely attributable risk. But so we have to understand it very well in order to move on to the other ones. So I decided to make this video just based on attributable risk. Actually, I will go back a little and talk about relative risk, which was seen in video number 4, last video. You can find it in the YouTube videos or Instagram. And we're gonna do that in order to understand in a better way what relative risk was, and that will help us understand what attributable risk actually is. Okay, so let's try to make this into a graph form, because if we try to imagine this, it will be much easier for us to understand it. So what was relative risk? So relative risk, as the word implies, relative, so it's relative to something. You're comparing something. What are we comparing in the different studies we do in clinical medicine? We're comparing exposure to an unexposed group. And if we're searching for risk, we're definitely thinking that the exposure is a risk, might be a risk factor, or might increase risk for an outcome. So relative risk is comparing the two. And how do you compare relative risks? You look at incidence, which the incidence in the exposed group is actually the risk in the exposed group. And you compare that to the risk in the unexposed group, which is the same as stating the incidence in the non-exposed group. What do you do? Okay, here we have percentages. So here we have a percentage of the exposed group with the disease. So here we know the outcome in the exposed, and here we know the outcome in the not exposed group. How do you calculate relative risk? You divide it. The incidence, this is the incidence in the exposed group over the incidence in the non-exposed group. That will give you the relative risk. So in general, if we're searching for risk, we're thinking of risk factor. So we're expecting this number to be more than 1 if there is a correlation. We cannot say that the relative risk is synonymous or analogous to causation. Of course, the higher the relative risk, the more probability that this might be a risk factor, meaning that it might have a causation with respect to the outcome. But that's not something we can infer off the bat. That is why you have to, in clinical studies, you have to try to make everything balanced out and just check for the risk factor you are searching for, and take all the confounding and bias out of the equation. And that's the way you can eventually find if this association and this number for the relative risk that goes from 0 to infinity is actually a risk factor. But in general terms, we usually state it this way, because if not, it would complicate our language a whole lot. So more than 1 means that the incidence in the exposed is more than the incidence in the unexposed, meaning that the variable we're searching, or the exposure, is increasing incidence, meaning that it's increasing the risk for an outcome. If the relative risk is less than 1, we're actually thinking it might be a protective factor because there is less incidence of the disease in the exposed as compared to the non-exposed. So something's happening and it's actually protecting us from um, generating the outcome. So this is the way you calculate relative risk. So what does it answer? So within y time, because risk, you in order to assess risk, you have to see things in a timeline. That's why we talk that relative risk is calculated in prospective studies. So within y time, what's the risk for the exposed to develop the outcome relative to the unexposed? So basically what this is saying is x times more than the unexposed. Okay, so this is telling us, okay, smoking um, increases the risk for heart disease x times more than non-smokers. Okay, now that was relative risk. So now understanding that, let's go use this same graph to understand attributable risk. So attributable risk has different synonyms you might read in the literature, and this will help us understand it because this attributable risk is the same as saying excess risk, or that is the same as saying risk difference. You can use it interchangeably. So let's try to make sense out of this. So we already knew how to calculate relative risk, which is dividing this incidence of exposed over this incidence of unexposed. But for attributable risk, we're doing things a little more differently. So relative risk is just talking to us and giving us a proportion, because you're dividing, for example here, 6% over 2% will give you 3, not 3%, because it doesn't have a unit. You are dividing a unit over a unit, so it's unitless, so it's a proportion. But attributable risk is giving us numbers of people or numbers of incidence rates. Why is this? Because attributable risk is finding out how much of this outcome is attributed to the exposure you're searching. Okay, so let's understand this. Let's first look at this square right here. This square right here is non-exposed group. But even it being non-exposed group, you're seeing they're having the outcome. What's happening? Could this be confounders? Could this be other factors that might produce the same outcome? We don't know. It might be both. It might be one or the other. What do we try to do with attributable risk? We try to cancel this out, and we try to know how much of the actual outcome is attributed to the exposure we are searching. So let's put this into context right here. Let's use the example of heart failure, and here we have the percentage of heart failure, and here we have the different causes of heart failure. So right here, these two are common. So 2%, let's draw the line right here, assuming this would be 2%. So 2% is produced by these two. Okay, exposed group, very similar to the non-exposed group. There you have a whole basket of diseases such as congenital heart disease, alcoholic cardiomyopathy, viral cardiomyopathy, chronic hypertension. But right here, the incidence is more than the non-exposed group. So right here you have an incidence much greater in the exposed group than the non-exposed group. Why is this group called the exposed group? Because you searched one specific variable to define as the exposure. Of course, these other things are exposures, but you didn't make the study in order to search for these other variables. So these other variables balance out. What you have is the exposure right here generating more incidence. So how can you define how much of this heart failure is actually attributed to smoking or the exposure? You have to risk difference. You have to do exposure group incidence minus non-exposed group incidence. Very simple. So in relative risk, it's divided them. In attributable risk, you have to subtract. That's the way you'll identify what is the risk attributed to the exposure. So what does attributable risk answer? Within y time, yeah, of course, once again, in order to define risk, you need time. So yeah, that's a common denominator in risk, in evaluating risk. Within y time, what's the excess risk or the extra risk? Right here you can see this is extra. This percentage is more than this one. So what's the extra risk for the exposed, or in other words, attributed to the exposure? And I believe that that's setting the scenario very clearly with this depiction right here that I have to thank Ambos application. They have this on YouTube, and I used this picture to generate this idea for you guys. And let's use an example. So here we have the same Ambos picture, but I just changed some things a little. So I made this column much higher and this one a little higher. So here we have the percentage of the disease. In the exposed group, we have 8%, and in the non-exposed group, we have 2%. So if I ask you, calculate the relative risk for this graph, what will you do? It will be exposed over non-exposed. 8 over 2 will give you 4. And if I ask you calculate the attributable risk in this example, what would you do? Pause the video. Yeah, that's it. You would do 8% minus 2%. Okay, so the attributable risk will give you 6. Okay, which one of these two is unitless? It is relative risk, because here you're canceling out. In a division, you cancel out units, but in a subtraction, you don't cancel out units. That's why this 6 has a unit. It's 6%. It's telling us that 6% of this outcome is attributed to the exposure. And here we have two answers. So tell me which one of these two will be, what number goes in each one of these. Fill in the blanks. It is times more risk of developing the outcome in the exposed relative to the unexposed. So if you just see the sentence, it's actually making you think about, look at this word here, relative to the unexposed. We're talking usually of relative risk. So it is 4 times more likely to develop the outcome in the exposed than the unexposed. And let's see this other one. There is blank percent, there's a unit. This could be 6%, or this could be the same as saying 6 over 100. So it's talking about incidence and incidence rate. There's a unit. There is 6% excess risk of developing the outcome in the exposed group. Okay, so now with this 2 by 2 table, let's move this around to see. Okay, no, nothing special. Let's make this smaller. So in this 2 by 2 table, fill in the 2 by 2 table and then calculate the attributable risk. So now you have the information. Now you can fill in this and calculate the attributable risk. Please answer this in the comment section below as question number 1. Question number 1, fill in A, B, C, and D. What's the value for each? And what would be the value for your attributable risk? I won't answer it for you because you can already do this alone with the explanations we already talked about. So I'm not giving the answer, so you guys answer. I'll be seeing the comment section, making sure that which is the correct answer. So I'll directly answer or respond to your comments. So let me know how you filled this in and how you calculated the attributable risk. And this is the formula for attributable risk. It's the same as saying incidence in the exposed minus incidence in the unexposed. But using this 2x2 table, what do we have to do? How do you determine what's the incidence in the exposed? Here you have exposure. So the incidence in the exposed is how many have the outcome in the exposed. How many have the outcome in the exposed? A. What's all the exposed cohort? It's A plus B. So it is A over A plus B. Then how do you get the incidence in the unexposed? You have C, which is, okay, these weren't exposed, but this one got the outcome. That's C. Over all the population that wasn't exposed would be C plus D. So that being said, there you have it. You can fill it out and let me know. And in general, attributable risk then is expressed as a rate of disease, not a ratio, such as relative risk. Let's see, it's the rate or incidence of disease in an exposed group that can be attributed to the exposure. You already know this. It gives the absolute amount of disease or number of cases. Yeah, it is expressed as cases per multiple of population. We just saw that in percentages. A percentage is 6% is 6 over 100 persons. If you want to manifest that over 1,000 persons, just multiply it 6 over 100 times 10. It will give you 60 over 1,000 persons. So this is something you can work with at a population level in order to determine the amount of disease that could be eliminated by removing the exposure. See why this is so important? Because the relative risk won't tell you this information. The relative risk, what it will tell you is this a probable risk factor? Yes or no? Okay. But the attributable risk will tell you, if you take the exposure out of the equation, how many lives can you be saving? So that will help you determine measures in the future to prevent illness. So we'll see this in one of these next examples. Right here, I want you to calculate the relative risk and the attributable risk. This is question number 2 in the comment section below. Tell me what is the RR and tell me what is the AR. You can do this. I trust you. And okay, there you have the numbers and yeah, calculate it. And this is a summary. You can pause this and read it through. And let's see, right here, this how much does goes right here, because this is not how many times. For attributable risk, this isn't how many times. This is how much does the factor of exposure increase the incidence. This just moved upwards, but this goes instead of many times. This is how much does. Instead, relative risk is actually how many times. You already know that it is just a unitless factor. There you have your summary. And this right here, we'll talk about this in the next video, so don't pay attention to this right now. And this is the utility of the attributable risk. This is a great example, which is from this article from 1985. So it shows us the relationship between relative risk and attributable risk and how they might deceive you. For example, let's look at smoking and would be the exposure for 2 outcomes. One outcome is lung cancer, the other outcome is heart disease. The relative risk calculated for lung cancer would be 23.7. That is huge. So it means that a smoker has 23.7 times the risk of developing lung cancer in Y amount of time as compared to a non-smoker. And the relative risk for heart disease is 1.4. So it seems a very small relative risk as compared to smoking and lung cancer. In this one, you would read it as a smoker has 1.4 times increased risk or relative risk of developing heart disease as compared to a non-smoker. Okay, perfect. But what can you do with that? if I just ask you, as a public health practitioner, you want to benefit the most amount of people. Your focus would be on decreasing smoking for the reduction of lung cancer or heart disease. So, based on relative risk alone, you might say, hey, this relative risk is supremely high compared to this relative risk. I want to reduce smoking and to reduce lung cancer. Those are the cohort of patients that will benefit the most. But wait, remember that relative risk is just telling you the risk of generating the disease, but it isn't actually telling you how much of that outcome is attributed to the exposure. What tells you that? It's actually attributable risk. So now let's calculate the attributable risk for those two illnesses. You'll see that for lung cancer it's 159, while for heart disease it's 177. So actually, you would benefit more people reducing smoking for heart disease than for reduction of lung cancer. That is the importance of attributable risk clinically. That's why we have to know it. And that's a great example. You can pause the video and calculate it yourself. I gave you the summarized format, but please pause it, make sense of this, think it through, and you have all the tools necessary to ace attributable risk. Next video will be on the other things we can calculate based off from attributable risk, what you can do with that. See you in the next one, and this is the bibliography. I'll post every link to this in my YouTube video because Instagram doesn't let me let you copy and paste. So this will be in the YouTube video.